Before we start building our Roku channel, let's review some core concepts. In this lesson, we're going to discuss the basic design principles for developing on the Roku platform, provide an overview of the Roku programming languages, and review the content and structure of Roku channels. You'll learn about SceneGraph, which is Roku's XML UI framework, BrightScript, which is Roku's scripting language, the different types of components you can use to build your channel UI, threading, event handlers and observers, data scoping, and graceful degradation. When you are done with this lesson, you'll be ready to start developing your first Roku channel. Streaming applications on Roku are referred to as channels. Creating a Roku channel involves two programming languages, SceneGraph and BrightScript. These languages are used together similarly to how HTML and JavaScript are used for designing web pages. SceneGraph is Roku's proprietary object-oriented XML framework. It is used to design the channel UI. BrightScript is Roku's scripting language that is used to define the channel behavior. Let's dive a little deeper into each of these languages. SceneGraph is used for configuring and rendering the channel UI. It organizes the channel into a hierarchical tree of UI components. At the root of the tree is a single scene component. It contains a number of child components representing the different pages in the scene. For example, a scene may contain a grid screen where users select content, and a details page that provides information about the content, and a play button. Each page contains a number of pre-built UI components, or nodes. This includes grids for displaying content, keyboards and buttons for handling user input, and video and audio nodes for playing back content. Each component is defined in an XML file, which contains the attributes that control the appearance and behavior of the component. You can use these built-in components as they come, or you can modify them into custom node classes. Creating and using custom nodes enables you to have UI elements with more complex appearance and behavior. Ultimately, these built-in and custom components form the building blocks of a Roku channel and make it easy to create a consistent user experience. Once a channel is launched, BrightScript works with SceneGraph to control the functional behavior of the components. Important common tasks in BrightScript files include initializing screens and handling events. For example, when the home screen is loaded, BrightScript is used to populate a grid component with video content. When the content has finished loading, an event handler stops the loading animation and sets the focus to the grid. Later, when the user selects a video, other event handlers are used to display the details screen and hide the home screen, and then load a thumbnail and information about the video in the details screen. All Roku channels have a standard directory structure. The root folder contains the manifest file, which contains the channel's name, version, and artwork. Every channel must have a manifest so the Roku OS knows which features your channel supports. Some of the common optional features you might declare in your manifest include support for enhanced voice controls, full high definition, and advanced deep linking. The SceneGraph components, artwork, and main application in your channel are all stored in separate folders. The components directory contains the SceneGraph nodes in your channel. The root folder in the components directory always contains two files: the XML file for the main scene and its corresponding BrightScript file, which has a .brs extension. To help organize your channel and make it easy to identify the functionality of different components in it, the components directory should contain folders for each custom node class in the main scene. The images directory contains the channel poster, splash screen, and any other artwork in the channel that is not retrieved from your server. The source directory contains a BrightScript file named main.brs. This file serves as the channel's main application execution thread. It is used primarily to create the scene component object, which starts the SceneGraph render thread. The main.brs file typically contains a single main function. This function can receive runtime arguments from the Roku OS, such as content IDs and types, for deep linking into content. Finally, a channel directory may also have additional files and folders for fonts, SSL certificates, a makefile, and so on. SceneGraph provides a robust library of components to create scenes. Components can either be renderable or non-renderable. Renderable components are drawn as part of the scene. This includes basic UI elements such as rectangles, labels, and posters. These form the foundation for more commonly used components, such as buttons, lists, grids, keyboards, and dialogues, which have more complex appearances and behavior. Non-renderable components are not drawn on the screen. These include timers, animations, and content nodes. These components support the scene by describing the information in it. Components are organized in a hierarchical tree. Components lower in the tree are rendered over the higher ones. For example, if a rectangle has two child components, let's say a label and a poster, those child components will be displayed on top of the rectangle. Now, as you move lower down the tree, the rendering state accumulates. This means that the state of a parent node controls how its child nodes are rendered. Using the previous rectangle example, the label and poster will have the same attributes of the rectangle, such as their visibility and opacity. Another important SceneGraph concept is threading. Roku channels support multi-threading. For example, when a channel is launched, the main execution thread in the main BRS file runs. The BrightScript main thread creates the scene component object, which starts the SceneGraph render thread. The render thread then draws all the renderable components in the channel. If your channel needs to read data from a server, manipulate file systems, or run any other operation asynchronously apart from the main and render threads, you can use a task node thread. A common use case for a task node thread is getting metadata from your content feed, then using it to populate a list or a grid with thumbnails and titles. In the render thread, your channel will frequently have to handle user input and events. An example of user input is when a button is pressed on the Roku remote control. The Roku OS includes an on-key event function to detect which key was pressed and execute code to handle the key press. For example, if the user presses back while on the home screen, you can program the on-key event to display a confirmation dialog before exiting your channel. An event occurs when the value or state of a component changes. For example, when a video is selected. The Roku OS has several built-in mechanisms to handle events. You can use something known as an observer to monitor when the value of a specific attribute changes. When the value changes, the observer calls a function to handle the event. You can also handle events using an event loop in the main or task node thread. In this case, you create a message port. The message port waits for a specific event to occur, and when it receives the event, you can execute logic based on the event type, the attribute that got updated, or the new value. You'll see how to create and use an event loop a little while when we start developing our channel. One last concept in this lesson is data scoping. Similar to traditional programming languages, a component can be made accessible to the whole channel application, or limited to the file, or the method in which it was defined. For example, a function that creates a dialog will have function scope by default. This means that the dialog can only be accessed from within the function. To make the dialog accessible from anywhere in the component's XML file, thus giving it component scope, you use the M-object reference. You can also use the m.top object reference to assign a component to the top of the SceneGraph tree. This is similar how the this object reference variable is used in Java. And finally, to give the dialog global scope and make it accessible to the entire channel application, you use the m.global object reference. You'll see these used throughout the examples, but let's just do a quick demonstration of this. In this example, the first method creates two variables with local scope and two with component scope using the m.attribute. The component variables are set to the value stored in the local variables. The method then prints out the results of adding each set of variables, which are the same. The second method creates two local variables with the same name, but different values, and then prints out the results of adding the local and component variables. The sum of the local variables is different as their values differ in each method. The sum of the component variables remains the same as the variables are accessible to both methods in the file. When developing for the Roku platform, Be mindful that the Roku OS supports several generations of players, TVs, and soundbars. These devices have varying performance capabilities. For example, newer devices have up to 4 times the RAM of older ones. So target your channel's core functionality for lower-end devices, while reserving the more complex graphics and animations for higher-end ones. In other words, follow the philosophy of graceful degradation. With graceful degradation, you include or exclude certain features based on the resources of the device running the channel. When designing streaming channels for smart TVs, the primary function is to make it easy for users to find content and play it seamlessly. All other features are secondary, and those features are the ones that may need to be excluded from devices with less processing power or memory. This is done to ensure that the channel can achieve its primary function. For example, consider the background images, content posters, and animations in a channel. To support lower-end devices, only render the absolute minimum number of images your channel UI needs. Also, host the images in the cloud. This way, lower-end devices can fetch lower-resolution versions of the images when they are needed. Similarly, you may need to limit your channel so that it only uses certain animations on higher-end devices. For lower-end devices, you can either omit animations altogether or replicate animations in a less expensive manner, such as switching between multiple still images. When designing your channel, always be vigilant about how you can maximize its power on high-end devices while ensuring it runs seamlessly on lower-end ones. Ultimately, you want to reward your users on high-end devices by creating an amazing user experience that leverages the power of their device. But remember that millions of users have lower-end devices, and you still want your channel to run on those. Other things to be mindful of include safe zones, which are designated areas within posters, splash screens, and your channel UI where graphics should be displayed. Keep your images and text within the safe zones to ensure that they do not get cut off by the edges of a TV screen. TVs have different picture qualities, therefore provide SD, HD, and FHD versions of the videos, images, and UI components in your channel. Finally, devices have a limited amount of texture memory. Minimize the number of images and avoid using unnecessarily large images to conserve this resource and avoid performance issues. Thank you so much for watching this video. For more Roku developer videos, subscribe to our channel. And for the rest of the videos in this course, as well as additional demos and tutorials showing you how to develop on one of the world's leading streaming platforms, check out the link to the Roku Developers video site in the description below.